Okay. Hello. It's really nice to be back at Build Stuff. This is like my 4th year here, so I'm pretty much like the furniture. I see some faces I recognize, some I don't, but for those of you who don't know, I'm Sam. I work at JustEat, which is a company in London. And the idea behind the company is you are hungry after a night out, or you're too lazy to cook. You go online, you put your address in, and it will shipped. They will get food delivered to you. So what's ironic is before people would be like, "Oh, like Uber Eats," and I'm like, "Yeah, but we're now in countries that that Uber Eats are in, and we're not. So we're kind of like Uber Eats, but we're kind of bigger. So not bigger than Uber, but we're bigger than Uber Eats." So we're going to talk about a lot of things today. We're going to talk about events, commands, CQRS, domain-driven design. If you guys see any buzzword that's not here, please give me a shout later and I'll add that in. So the point of today's talk is really the one goal I'm trying to give you is to try and understand why you're employed and what value you're delivering. So I've been in a lot of places where I've been in situations where we're getting in feature requests raise your hand here if you're a developer or an engineer. Okay, so most of the room, good. So I'm sure you can empathize with this. You've ever been in a situation where you've been asked to do a feature or you're asked to deliver something and you're sort of saying, what is the point of this? Like, why? Why are we building it? I know what we're trying to do, but why? And I've been in situations like that a lot, mostly when I have to work with marketing. And the goal of this talk is to sort of closely align the business with tech, and that's sort of why Agile was sort of brought into place. And the first question you ask yourself is, if the goal of this talk is to align and understand what value we're delivering, well, we work in Scrum, and we have daily stand-ups, and I sort of understand what I'm building and what we're building. But you're still in the same situation where you're asked to do something in your stand-up, and you're like, I don't understand the point of this, but okay, we'll build it. And that's actually a frustration. You should be really happy and proud to come into work because we're in a very unique industry. I mean, we learn from our failures. Then people were like, okay, we'll try to understand the code bases behind this, which will help us understand the value we're delivering. So TDD came into place, and we're like, okay, this will help us run ship manageable software, help us understand what we're delivering, and if people come in and sort of say, how does this piece of work, what is this value we're delivering, what's this feature we're trying to write, you can say, look at the tests. That doesn't actually work very well because you've been in situations where the language in the code base doesn't actually reflect the actual conversations you're having with the business. As an example, I've been in places before where you'd have this Three Amigos approach where you're asked to deliver a feature and you're sort of saying, okay, we've got to do this thing with saved cards. This is previously, and you go into the code base and you try and understand and go through the I call it the string, and understand where this is particularly being used, and you realize that the language being used in the code does not reflect what you communicate with. So in this particular example that I was talking about, saved cards were called tokenization service. And the reason for that is because the developers who built it were looking at the payment provider documentation, and the domain language of the payment provider was called tokenization for a saved card. And that makes sense, but it's not the business language, so it's ubiquitous language basically, that's the term. So that's when BDD came into place, and we were like, okay, we're going to use the exact same language that we use with our conversations, and that will help us reflect the language in the code. And also, a lot of that was pushed to say, if any stakeholder comes and asks you how this particular thing works, you're able to just point them at tests and just say, look at that spec flow test. This is how the thing works, and that's it. Job's done. But that didn't work either, because people were like, actually prefer having real conversations than looking at documentation. So I really want to stress that everything I'm going to talk about today is not replacing any of this. They work very closely alongside this. It's supposed to work where you're shipping software frequently, whether it's daily, weekly, bi-weekly, and it's not meant to replace it. So you're sort of, okay, what is it? What is this thing I'm talking about? And it's actually fully understanding everything that goes on in your application to the point where everything a user's doing with your platform, everything a consumer's doing with your product, to how long it's taking to respond, to even how well boxes are running in production, whether you're in VMs or EC2 instances, for example, if you're in the cloud, but everything that's happening. And when you talk about things like this, how well a server's running, how hot a box is running, how much free memory, how much CPU is being used, you sort of ask yourself, well, that looks like an ops job, right? It doesn't like, I'm here to deliver features, not look at how a box is operating in production. And while that's true to some extent, engineers are the ones who built it, right? We've got the deepest insight to how something works in production because we've got access to the actual source code. We can look at exactly line by line and understand what is supposed to be happening and why it's happening. And if there's an issue, identify it very, very quickly. So the benefits, before I joined JustEat, the benefits I did not see. I only started appreciating the benefits of this when dealing with issues in production. So previously, in my previous companies, when we had an issue in production, we would all sit in one room and try and understand, we call it the war room, try and understand what caused this particular issue. We'd try and look at logs, and because it was a distributed system and we didn't use centralized logging, there was a lot of RDPing into boxes to try and understand what was happening, what caused it, and more importantly, the impact to the customer. Like how much is it affecting user behavior? The immediate benefit I saw, it's one of many, but that's the first one I saw, was when dealing with actual outages, when dealing with issues, when you know it's everyone is in mission critical mode and trying to deal with issues. So the first thing I saw was we're not RDPing anymore because we use the ELK stack. We're shipping logs into Logstash. This is where we initially go in to see what's happening, and the conversations that we're having are validated with proof, which everyone can see. Like you don't RDP anything. And if you've been in Polstack talk just before lunch, that's really bad practice. Just stop RDPing into Box and get centralized logging. The next thing that I started seeing was it focuses. It tells us to focus on actually what matters, in the sense of where there's an issue in production right now. How many users is it affecting? Is it actually something that we should be getting out of bed for because we're on call for this? And having everyone focus on the exact same problem is really powerful to get us to proper solutions. So with all these metrics that we're pushing, we're able to experiment more, and we're able to try something, try new tests, see if we're working, and then we get immediate feedback. It's so fulfilling when you push a new feature and you start seeing users use it by the minute. And that tells you how well it's doing in production, and gives you an immense amount of accomplishment, that you're like, that's something I wrote and it's being used right now, and how it's being used and how we can improve on it. So that's some of the benefits I saw. So now we're going to the nitty-gritty and what exactly are the metrics I'm talking about. So the first one are business metrics, and these are counters. So these are things that occurred within your platform, like things that happened, logins, orders, searches. These are actual behavior events to your product, and these are the things that the entire business cares about, because this is core to your domain. Like if you're an e-commerce company, for example, things that adding things to the basket, removing them, searching, paying, what type, how you're paying. All these are increments. So you're incrementing. This happened once. This happened once, and it's a fire and forget. So you don't wait for an acknowledgement. It's just fire and forget. So you don't deal with concurrency issues, for example. And this you expose to the entire business to say, this is how things are in the platform right at this minute. The next type of metrics are application metrics, and these are one level down, where you're thinking, okay, someone made an order, but how long did it take for this particular API to return or this particular repository to return from the database. And these are timers, like how long, it could be milliseconds, seconds, probably should be milliseconds to be honest, how long something's taken. And you're able to look at, if you pushed a new deployment and suddenly someone tells you, oh, searching's slow, or doing this particular thing is slow, it's so vague and you don't even know where to begin. But now this gives you the ability to sort of pinpoint where it's slow, because you can tell, okay, you made an order here, by the time you got it back, it took X amount of milliseconds. You can start pinpointing what caused it to actually be slow. So then one level down is the infrastructure metrics, which are, how much memory is on the box, how much CPU usage is being used, how much of the hard disk is being taken upon. And these are extremely bare bones. You don't actually share these with people who are non-technical. These are within the engineering department and perhaps the ops department if you've got one. And this gives you an idea to, if something was running slow, why it's causing it. It might be the fact that it's a 90% usage or 100% usage, it's just taking really long time. And it might be something that, a code change caused, but you're able to see it. And that's the most important aspect, that you're giving visibility to this. And there's a trend here, we're just following where the money comes in. As in when the customer starts hitting your website, you're following through down to the actual box level to find out exactly what they're doing. And this gives you immense visibility into the behavior of your consumers into your platform. So you're like, okay, that sounds really good. I want to hear that, but how do I go about changing my company culture to do this? Because this sounds amazing. It's probably the best talk you've ever heard. But you can't, right? You can't. You're going to fail. If you go and you say, oh, we had this amazing talk and we want to implement it, you're going to fail. Because changing an entire culture like that is suicidal. The best thing you can do is you work really, really tiny. You start extremely small and you work with the people you work with, your team, right? We're all developers here, we're mostly engineers. We're all employed to deliver value. So you come into work and you're like, okay, for this day or for this sprint or for this quarter, what is our main goal? Every team has a main goal, right? That's why they're employed. And what is our core goal? What is our core metric for this sprint or quarter or whatever? And then give it a name. This is what, so for example, if you work in conversions, we want to increase conversion by X amount of %. That's our core goal. And you start collecting data around it. You start pushing only business metrics. You start really small, but then this helps you focus any sort of conversation to pushing that one goal that's on the whiteboard, that's on the screen. And if you ever have requirements that come in where it's somewhat vague and you're like not entirely convinced, you can all have a conversation to say, how does this one thing push that metric? Because that's what we're here to do. We're here to push that goal. And then that really obscures away all the stuff that are perhaps politically hard to deal with for people like myself, basically, because I'm really rubbish at politics. It's really simple how to push a metric. We use StatsD and Graphite. But there's loads of clients out there for this. For example, with this, you want to counter and say, these are the number of attempts that happened. You can push successes as well. You don't really need to push errors because, successes minus attempts minus successes is errors. These are the timers, how long a particular thing took. And this is the gauge for the CPU usage or RAM usage or disk usage and so on and so forth. And there's loads of clients out there for pretty much any language that you're using. I'm not sure about PHP because I avoid that. But most other languages you can find. And it's literally just simple. And you've got, for you to set up a new StatsD server, there's loads of baked AMIs, Docker images. You've got, you can just go into the Amazon marketplace and just say spin up a new Graphite server, and then all you need to do is get the host address or the IP address and push it. If you're in another cloud provider, it's the same. They're baked images that you can just spin up. A really good tip is don't really measure everything, because now you're like, okay, now that I have this visibility of everything, it becomes really addictive and you want to measure every single thing. You want to know what everyone's doing, things that you think might not be important, but it might be important in the future. This will lead you to really get confused with all the level of data that you're coming in. You start really small and you just start collecting that one important goal that you're employed to do. And slowly, you're going to get it wrong the first time, but you slowly iterate over these metrics and you start defining what's important and what's not important. And the more you start sharing it, the more people realize its value. The aim is really to fail fast in this, right? People are always talking about velocity of their sprints and how fast they're deploying. But Goiko has this really good talk called impact mapping, and they've got a book on it. So the idea is you're in a car and you're constantly traveling really fast, but you don't even know if you're going the right way. So this allows you to sort of measure that you're going the right way and be happy of failing really fast and saying, okay, this thing we thought was going to push this metric isn't, so let's try something else. And that's the goal. And you make pretty much any future decisions based on the one goal you're employed to do. And you grow it as you grow your team or you grow your entire department. You start making any future decisions that you have to do, any future features you think will be really cool, you base it on the metrics that you have and historical behavior. Because you're making your decisions based on data. Useful techniques that we've had. The first one is feature toggling or canary releases. This allows you to avoid the hard deadline, basically, because you enable features. So for example, we were working on a feature to implement PayPal in one of our countries. And we wanted to phase it out. So you'd feature toggle it and you'd phase it out to like 1% or internal customers first, then 1%, then 5%, then 10%, and you just gradually roll it out. Because that gives you the confidence that it's constantly running in production. And by the time you go to 100%, you can comfortably tell your stakeholders, this thing's been running in production now for 3 months. We're 100% confident that it will work. Another is to alert. Now, your domain experts know the historical behavior of your users. They know what's weird and what's not. For example, if you were working on a website that allows different types of card providers, and they're like, well, we normally see 30% people pay via PayPal, 60% pay by cash or card, and so on. And then if you suddenly see different dips of that behavior, that's the system telling you there is something that you should know, and you alert on it. And really, an alert is just a test running in production, right? Instead of just one acceptance test that says someone can log in and someone can make an order, an alert is just saying someone can continuously log in. And when the baselines look different, like the number of login attempts are X amount more than the successes, that's when you raise an alert because you have suspicious behavior and a test has failed in production. And it's basically just saying there's suspicious behavior. Now, you could have a big campaign that goes off and suddenly you've got 20% more traffic. But that's still something you would want to be aware of. And this is really powerful because then you could, when you have customer services people saying there's a problem and you tell them we're already aware of this problem and this dashboard we shared with you shows you how we found out and when it will be resolved, they have a lot more faith in the tech team in general. We have a single source of truth, which is Elasticsearch, Logstash, and Grafana. I'll show you that in the demo later. But basically, Elasticsearch is just a free text search engine. Logstash is where we keep the logs, and Grafana is just the UI, which allows us to run queries to find out when there's an issue. We say, give us an example of an order ID, and then we try and pinpoint exactly what happened with that particular user journey. Rather than overall flow, which we get from the metrics. This basically gives us a credible visibility of the platform. We know exactly what people are doing right this second, well, right this minute. We know what people are doing last week. We can compare the behaviors with the week before. We can see how well a feature is running. If you suddenly implement logging via social network because you believed it will increase conversion, you can see how many people have been logging via social network. How does the conversion compare with people who log in normally? And if you feature toggle it, you can say, okay, this is going to X amount of tests. This is more like A/B testing. You say, okay, we suspect this metric will improve if we do this particular thing, and say you deploy this thing and you start measuring how well people are doing in test A and test B, and then you go with test B. And again, you're pushing every single decision you're making based on real results. And more importantly, you share these graphs with everyone. Everyone should have accessibility to these graphs. It's not just a tech thing. Even though you have them on your screen, it's really useful to always have them on your dashboards, and you're able to view them every single day. It's really important to share them with everybody in the business, because that really helps them have these conversations and notice things that perhaps tech-minded people might not see. Seeing behavior, seeing patterns might be useful from a different view. It's basically rubber ducking, but in a massive scale. And more importantly, it's options, right? So we had a situation where suddenly the saved card service I was telling you about broke, and we were in a situation where it was high alert. We're losing a lot of money. It's a rubbish experience for the customer, because they come in, they try and pay for something with their saved cards, and it doesn't work. And when you give a user an option it doesn't work, it's a really rubbish experience. So really, the business understands that there are situations that like these occur. They want options. They want the ability to say, okay, this is an issue, what are our options? And for you to tell them, okay, well, this thing's broken because of our dependency to our payment provider. What we can do is we can switch it off. So users will come in and say they can pay with a variety of different sources, but the one source they were used to paying doesn't appear. That's still a better experience than giving them that option and then failing later on. Another really useful technique that might take you a while to convince your stakeholders about is fake load. So we push a lot of fake load through our system. So what's surprising and what really was an eye-opening experience for me is you've got business people or salespeople having projections. They project the platform, or they project the business will be doing 20 or 30 or 40% more traffic in X amount of months. But tech teams rarely ever sit down and say, look, this is what they project. Can our platform handle this load? We never do that. We're always reactive to saying, okay, we're suddenly having X amount of load now. How can we cope with it? So we came up with a solution where we're constantly trying to prove what we're doing. And what we're doing is we're pushing 50% of traffic from 3 months from now into our system today to prove that we can deal with it later on. This gives us the ability, if we ever come up with a scale problem, to switch it off and suddenly get more capacity. So to put it in numbers, say we're doing 1,000 orders a minute, and we think in X amount of months we're going to be doing 1,500. We push 1,500 now. So when a couple of months down the line, when we are doing 1,500 real orders, we'll be pushing 2 or 2,500 extra. And then we have an issue. We kill off that fake load, and suddenly we have amount of capacity that we've already proven we can take 3 or 4 months ago. So there's a few things that you have to do with your platform to enable this, but it's a really powerful technique to be used. It doesn't matter if we suddenly came into a scale problem, because we've already proven that we can handle it months ago. So now I'm going to show you some of these graphs in the hopes to actually visualize what I'm talking about. So really, really quickly, what's the easiest way of doing this? Right, so maybe if I mirror these displays. Right, and then close that. So this is an example of, wait, hang on. This is an example of application metrics, but I guess this will probably be more important to you. These are people trying to pay. These are attempts, so these are business level metrics, and we can see how long it's taking. And we have real load versus fake load, and so on and so forth. So these are all business level metrics. The next is my internet's gone, so this is not showing, but I'll try loading a different graph. So these are application metrics, so these are all our dependencies, how long they're taking, and we can set alerts, so we know this APIs or this set of dependencies take this long to reply. So when they're above average, we can alert on that to define how long they're taking. And finally, we've got the box. Okay, fine, give me the last 2 hours. And you can see how much memory is remaining, and again, these are how you define what normal looks like to you. This is all very, very specific to your domain, to your business, and what normal is to you and your team. Right, so let's try and right. Will that still work? Right. So, questions? Oh, sorry. I'm going to walk over there if that's okay. At what stage of development, from the dude, okay, at what stage of development would you start measuring? It's very, very early stages, as soon as you've got data, as soon as you've got real customers. So you can test this where you're pushing in your QA environment the user flow, but really you don't want to measure in QA. You want to measure in production. So that's when you start measuring, when you actually have real data to share with the rest of the team. This is what people are doing in our platform, and that's when you actually start sharing. I hope that answers that one. This is from MS or Microsoft. I'm a bit worried they're listening to us, but okay. How do you handle data structure changes that uses then using feature toggle? Well, the feature toggles are all, there's loads of frameworks that you could use. Our feature toggle system is something we wrote internally years ago, which just looks into the database and says, is this feature on and off? So it doesn't actually have anything to do with the internal data structure. So maybe I'm misunderstanding the question, but the feature toggles are completely separate to what data is being collected. Feature toggles just tells you, is this thing on, and can the user go down this path on the website or in the product? ST says, would you see the use of log files to scrape metrics and build dashboards by a tool like Splunk and Anti-Pattern? I don't know, because it all comes back to how you build. And if you don't want to build your own custom metrics, which I don't understand why you should, because they're defined to your company. But if you feel like you shouldn't and you want to just use the logs as something that has happened as your metric, that's fine. I wouldn't use it because you can't really then share it across the business. You have to do more work to make the language more clear to non-technical people. But it's really up to you. It's not my place to tell you what that you're doing, whether it's doing is wrong or right. It's just not something I would do. Are you running anomaly detection and root cause analysis on top of your time series metrics? How would you tackle alert fatigue? So we had situations where the alerts were too sensitive. And we've had situations where people were woken up at 2 in the morning because of a blip. So there isn't a good answer to that. It's something that you learn as you go along, which is, this is what looks like normal, and if it's not normal for X amount of minutes, that's when you alert. But there isn't a surefire way other than pure experience and trial and error that I am aware of. And when we do see an anomaly, we have stand-ups the next day to say what caused that particular issue, especially if it's been occurring over time, and all hands are on deck to try and fix that particular issue. The reason being is when we have an issue that keeps happening, we kill off fake load, and suddenly we don't have that safety net that we have. So everyone is completely focused on getting the ability to run fake load again, which means not alerting because of it, to try and identify what the issue is. What dashboards do you prefer? I really like Grafana because the UI is really nice and I'm able to create metrics as easily as I want. But from my understanding of what Microsoft is asking here is which of the dashboards do you prefer metrics-wise? That all depends on the team. I prefer what we're working on because I want to know how well our team's doing. I don't actually look at the dashboards of the other team because it's very easy to get lost. You could look at the very highest level dashboards for your business to know how well the user is going to your platform, but I don't look at the dashboards of other dependency APIs because I only care about, it's encapsulated, right? I only care about me and my dependencies and how long they're taking to respond. When using events, did you ever consider using a time series database like Grafana, or is it the ELK state the best fit? Well, we're using Graphite for our time series metrics. The ELK stack is when we're looking at logs. So when something does happen and our metrics indicate there's a problem, we look at an example identifier, and then we go into Logstash to try and find through the logs what has happened and what caused it to happen. Maybe it's an exception. So we don't actually use Graphite as a time series database. We don't use the ELK stack as a time series database technically. Which component analyzes logs and converts them to alerts? So we use Siren, and Siren, what Siren does is it's the same thing as looking at, as the dashboards, and it's looking at metrics. It's really simple. All it's doing is doing really, really rudimentary mathematician. It's just doing maths, right? It just says, okay, if the number of attempts and the number of successes is below a certain threshold, so it does successes over attempts, and if it's less than 0.7 or 0.8, which is 80% or 70%, raise an alert. It's really very, very stupid, and you want it to be very, very stupid because you want it simple. You want it simple, anyone can set up an alert. I think that's pretty much all of them. You're welcome to, does anyone else have questions I didn't cover? Okay, thank you very much. Oh, we got one. Yeah. Yeah, absolutely. I know it's a lot of buzzwords. I should have added them to the buzzword bingo thing. I'll do that next time. Go on. So we have a header that identifies when an order is fake because we don't want to send it to restaurants. And we have certain restaurants that we test through. Now we're pushing it to everyone. So the more we exercise of our system, the more validation that we have that it works. But we have a header, so we don't try and attempt payment on these orders. And we don't try and send them to restaurants. But we also add the latency. So if a normal order takes 200 or 100 milliseconds to return from dependency, we add that delay to fully mimic real traffic. But we've got headers where our components are able to tell this is a fake order. And it's only the components that are talking to the external parts of the domain. The rest of the system has to be oblivious, because otherwise you just have if statements all over the place saying, oh, it's fake traffic, I'm just going to return true. And you don't want that because you're defeating the point. Any further questions? Yeah. There's not yet. It's a lot of people have talked about it. I'm not the first to talk about it. Actually, the first person who talked about it was someone from Lithuania, which you can Google. I think his name was Vidas, but don't quote me on that one. We're not the first. I'm not the first one, but I might write a book now. Probably going to be a series of blog posts and then a book, because I'm not a very good writer. And feedback, right? So I'll fail fast, and people will tell me what I'm writing is crap, and then I'll make a proper book about it. Any further questions? Right, thank you very much for listening. I hope you enjoyed yourself.